Hi, my name is Muhammad Amirul Ali bin Ziki. My metric number is AS11477. The subject is biology, and the code is ASB0204. And the date I finished recording my video is 16 November 2020. So the topic of my presentation today is invertebrate deuterostome. Okay. So this is the content of my presentation today. First is the deuterostomia. Okay, deuterostomia. Second is echinidum. Under echinidems, there are 5 clades, which is Asteroidea, Ophiroidea, Echinoidea, Crinoidea, and lastly Hollanthoroidea. Okay, so this is the dysprotomia, the taxonomic of the dysprotomia. First, we start with the protists or the ancestor. So from the ancestor, they are differentiated by the tissue and by bilateral symmetry, and lastly by the deuterostomia. So this is the dystrotomia. So under dystrotomia, there are 2 members, which is the echinoderms and the chordates. So I will explain about the echinoderms, and the other presenter will tell you more about the chordates, but mine is the echinoderms. So let's go. First, what is echinoderm? So echinoderms come from Greek word, which is echin, means spiny, and derma, means skin. So this is the properties of echinoderms. So if an animal does have these properties, so it means that it is echinoderm. So what is the properties? First is the animal is slow moving animals. Next is they are sessile marine animals. Also, the most important part is that they have a thin epidermis covers an endoskeleton of a hard calcareous plate. Okay, so next they are prickly from the skeletal bumps and spines, so they are very spiky, very spiky. Like the sea echin, some of them are not that spiky, but some are very spiky. So next is this is the specialty of the unique feature of the echinoderms. So echinoderms have this what we call water vascular system. Only echinoderms does have this. So what is water vascular system? Water vascular system is a network of hydraulic canals that branching into an extension called as tube feeds. So what does this water vascular system do to these echinoderms? So the function is water vascular system helps in locomotion, in feeding, gas exchanges, and sensory receptor. So there are 5 class of echinoderm. The first is Asteroidea. The common example of Asteroidea is the starfish or the sea star. We also call them as a sea stars. So the properties is that the Asteroidea has 5 to 40 arms. Okay, next is Hollanthoroidea. So Hollanthoroidea, the common example is a sea cucumber. So Hollanthoroidea have a long leathery skin, a long leathery body. So next is Echinoidea. So Echinoidea, the common example of Echinoidea is a sea echin or a sand dollar. So Echinoidea, the properties of Echinoidea is that they use their spine for locomotion, defense, and burrowing. So Echinoidea use their spike thing to moving, to defense, and to burrowing. So next is Ophiroidea. So the common example of Ophiroidea is a brittle stars. Okay, brittle stars. So Ophiuroidea have a central disc surrounded by 5 arms. Okay, they have a central disc surrounded by 5 arms. So next is the crinoidea. So crinoidea, the common example of crinoidea is crinoids. So the other name of crinoids is a sea feather. Sea feather. Okay, so crinoidea have a stalk feather stars and motile feather stars. Yes, this motile feather stars. Okay, next. Okay, so let's go into asteroidea first. Okay, so this is the characteristic of asteroids or asteroidea. So like other asterozoans, asteroidea have a characteristic of star-shaped body plan, so consisting of a central disc and multiple, typically 5 radiating arms. So normally for asteroids or asteroidea, they have a multiple of 5 arms. So the sea stars or the starfish may have 5 or 10 or 15 or 20 up to 40 arms in a multiply of 5. Okay, next is asteroids are most easily distinguished from other asterozoans, commonly from the Ophiuroidea. So asteroids are most commonly distinguished by the Ophiuroidea. They kind of look the same by the structure of their arm. So next is asteroidea. Skeletal support for them is provided by the ossicle of the body wall, which merge with those of the central disc, giving the arm a very broad base attachment to the disc. Okay, so let's go to the next. Okay, so this skeletal arrangement, allows for the extension of a comparatively large coelamic cavity. Remember, coelamic cavity from the central disc into the arms, which serve to hold some of the animal's organ system, namely the gonads and pyloric caca. Don't be afraid if you can imagine this. I'll put the picture after this. Okay, additionally, this skeletal arrangement also limits a lateral flexion of the arms. Okay, so this is the picture of the oral side. This is the oral side. We call them as oral side, and this is, we call them as aboral side. Remember, where the mouth is the oral, where the back is the aboral, applied to all animals. Okay, so let's erase this first. Okay, so let's continue. Okay, so this is the arm, or we call them also as the wrist, arms or wrist. So this is the central disc. This is the central disc. This is the mouth, and this is the umbilical groove. We call them as umbilical groove under the oral surface of the asteroid. Okay, so next let's go to the Ophiuroidea. Okay, so Ophiuroidea are a large group, over 1,600 species. They are the biggest member of the echinoderms. So Ophiuroids are a large group of over 1,600 species of echinoderms. That includes brittle star, or the other name of brittle star is Ophiurida, and the basket star Euryalida. So the more family of Ophiurida, or the brittle star, the other name, usually have 5 arms and superficially resemble true starfish as asteroida. So however, the brittle star have a long and flexible arm, brittle star have a long and flexible arm. Hence, the other common name for Ophiurida is snake stars and a central armored disc sharp body that is clearly demarcated from the arms. So, like I said earlier, Ophiurida are commonly be distinguished by the Asteroida. So, why? Because okay, we'll go through the picture after this, and I'll tell you more about this sentence. Okay, I'll tell you more about this sentence. Okay, I'll tell you more about this sentence later when we go at the picture later. Okay, so instead of crawling on hundreds of feet like starfish, so starfish use their tube feet for crawling, for moving, for locomotion. Brittle stars move very rapidly by wriggling their arms. So for your Ophiurids, they are wriggling their arms because they have a more flexible and more longer arms than the asteroid, right? So they use their wriggly arms, they use their arms and wriggle to move in locomotion, to move and to locomate. So instead of using the tube feet. Okay. Next, these agile arms are supported by internal skeleton of calcium carbonate plates that superficially look like vertebrae, and they are in fact called as vertebral ossicle. That arm are very strong, are very flexible, because they are supported by internal skeleton called as calcium carbonate plates. This calcium carbonate plate also called as vertebral ossicle. Okay, so these are moved by a system of muscle and linked together by a ball and socket joint. So the body and arms are also protected by the calcium carbonate plates, and the arms are generally by delicate spine. The arms have delicate spines, and they are very strong also because they have these what we call as calcium carbonate plate, but just like this sentence tells us about. So they are moved by a muscle that link together by a ball and socket joint. Okay, so this is the picture of the brittle stars. Okay, this is the picture of brittle stars. Okay, at the first thought, what did you see? You must be thinking of a starfish, right? Yes, that's why the Ophiurids are commonly be distinguished by the Ophiurids. So if the starfish, they have like these. Okay, this is starfish, while for Ophiurids, the asteroid. Okay, asteroid. Okay, so and this is the brittle star. The name is brittle star of Ophiurida. The other name is Ophiurida. So this is the arm. The arm is longer than the asteroid. The arm is longer, are more flexible. This arm are not flexible. This okay, so this is the central disc. So this is the zoom version of the central disc. So this is the mouth. This is called as oral site. Remember again, this is oral site, and this is the aboral site. So this is aboral site. So at the center, this is the mouth. So this is a closed umbilicum. The white is the closed umbilicum. This is the oral shield made of calcium carbonate plates. So this is basal slit. This is the white thing little here. This white thing little is called as basal slit. So at the first thought, you must think of the starfish, right? No, this is not starfish. That's why the sentence that I read earlier, states that the asteroids are commonly distinguished by the ophiurites because of their arms are kinda look the same. Okay, so let's move to the next slide, which is the echinoderm. Okay, so let's move to the echinoderms. Okay, so like all echinoderms, like all echinoderms, echinoids are pentadially symmetrical. Echinoids are pentadially symmetrical. What does this sentence means is echinoderms, most of echinoderms are shaped like pentagon, pentadially. So you know, this is the brittle star. Okay, so this is the brittle star. The shape is pentadial. The starfish, the shape is pentadial. So all echinoderms commonly is a pentadially symmetrical. Okay, so let's erase this. Okay, let's erase this. Okay, so here, so like all echinoderms, echinoids are pentadially symmetrical and have a water-vascular system. You just remember all echinoderms have this water-vascular system and have an internal skeleton made of calcitic ossicle, also called as plates. The calcitic ossicle or calcitic plates. A distinguishing feature of the echinoid is that the ossicle imbricates and fuse into a globular or discoidal test. Its flattened or concave oral side faces the substratum and the orbital side is arched in the most species. Okay, the mouth in the peristomal membrane contain a powerful chewing apparatus called as Aristotelian lantern. Okay, so echinoids have this the mouth has a peristomal membrane that has a powerful chewing apparatus called as Aristotelian lantern. Okay, so this Aristotelian lantern is composed of 5 jaws. They have 5 jaws in the mouth and is capable of extending through the mouth of some echine. Okay, the mouth leads to intestine and the anus, and which is located in the center of a oral surface in the regular echinoids. For regular echinoids, the mouth leads to the intestine and the anus, which are located in the arboreal surface. Just remember arboreal and irregular echinoids. For irregular echinoids, the anus is either posterior or on the oral surface. Okay, so this is the picture of echinoids. Sea echine. This is a sea echine. So this is what we call as mandriporite. This is mandriporite. This is the anus. So this is the mouth. So what do you think? Is this irregular echinoids or regular echinoids? Okay, if you think this is a regular echinoids, what do you think? Okay, so if you think this is a regular echinoids, yes, you are wrong because this is irregular, because this is irregular because the anus are at the arboreal side. Okay, so this is the mouth, this is oral side, this is arboreal side. Okay, so at the arboreal side, irregular have the anus at the arboreal side. Okay, so this is the spine or spiky. This is what we call as tip feet. This is the ampullae. And this is, okay, let me erase this for a second. Okay, so this is what we call gonads. This is gonads. Okay, this is gonads. So this is the pharynx. This is Aristotelian lantern. this thing here, this is a totally lantern here. This is a totally lantern. Okay, so let's move. Okay, so you can see this video. Okay, let's see this video together.
Along the coast of California, ocean currents carry a constant supply of nutrients up from the depths to the surface layers. These upwellings fertilize forests of giant kelp that thrive in the summer sunshine. The algal towers are as high as a 3-story house, and they can grow by half a meter a day. Life in the kelp is as full of drama as in any other forest, but the cast is less familiar. An army of sea urchins is mounting an attack. The urchin plague strikes at the kelp's holdfasts, their crucial attachments to the rock.
Okay, so you can see that they wriggling their spine to move. Okay, so they're wriggling the spine to moving and for locomotion. Okay, so let's watch the video again.
Along the coast of California, their crucial attachments to the rock. Holdfasts are extremely tough, but each urchin has 5 teeth which are self-sharpening and are replaced every few months. Urchins fell vast areas of kelp forest, creating clearings known as urchin barrens. Yet, barrens is a poor description. Millions of invertebrates invade the seabed. The most fearsome predator here is a giant. The sunflower starfish is a meter across, with an appetite for brittle.
So let's stop here. That is starfish, by the way. Okay, so let's go to the next slide. Okay, so let's move forward to the crinoidea. So in crinoidea, there are 2 body regions called as the calyx and the rays. The rays are the arm, remember? So the calyx and the rays. So the calyx is the car-shaped central portion that lies below the oral surface, which oriented from the substrate. Most of the organs are found in the calyx, so most of the organs are in the calyx. Both of the anus and the mouth open on the oral surface. Remember, the anus and the mouth is where the oral surface. The mouth, where the mouth located, that is the oral surface. But the anus is easily distinguished by being located atop an ossified concept peripherally on the oral surface. So the anus and the mouth are easily distinguished because both of them are at the oral surface. So the rays, the arm, like extension from the calyx, they are used for feeding. Okay. Next, each ray has a lateral row, of short branches on either side. These pinnules increase the surface area and trap food. Some of deep sea crinoids have a third body portion like the stalk. So some of the deep sea crinoids have the third body portion, which we call as the stalks. So the stalk is served to anchor the crinoid to the substrate. The stalk is largely comprised of stacked calcite discs. So the calcite discs are stacked and form the stalk. They are commonly fossils in limestone. Okay, so this is what we call as this is what we call as sea feather. This is sea feather. Okay, this is a sea feather. Okay, so you can see that there are like a feather. That's why they call a sea feather. Okay, so okay. Okay, so this is the crown, and this is the stalk. This is the arms, or we call them also as the rays. This is the pinnules that stick to the arm, to the rays. This arboreal carp, the arboreal carp. Okay, this is the arboreal carp. Cup shape. Remember calyx. Okay, so this is the columnar, and this is the whole false. Okay, so these crinoids use their arm to locomote. Okay, let's see the video. Okay, this is how the sea feather or the crinoids moving by wriggling their arms. By moving their arms like a feather, they moving like a feather. Okay, so this is the hold fast. This is the arm or the rays. For further explanation, I have a video for you for further explanation by the ML Studio speaker, Arif Haikal Anafi. So let's hear what he will talk about these crinoids.
Hai, kembali lagi dalam rancangan binatang apakah itu? Kali ni kita nak ulas satu video yang mana macam ada pelepah dalam air, dia berenang dalam air kan. Mesti korang nak tahu binatang apakah benda tu dan macam mana dia boleh berenang macam tu. Adakah dia betul berenang ataupun dia terbang dalam air? Sebab dia pelepah kan, macam pelepah mestilah ada terbang, pelepah, burung terbang. Macam itulah kot berkaitan dia. Pertama sekali, binatang yang korang nampak yang dalam air tersebut ialah dikenali sebagai sea feather. Sea feather ni ialah kelas yang sama tara dengan keluarga tapak Sulaiman. Kenapa dia bergerak macam tu? Mula-mula sebelum kita nak pergi kepada macam mana dia bergerak macam tu, kita kena tahu dulu organ-organ yang terlibat dalam pergerakan tersebut. Pertama sekali, organ di tengah-tengah pada sea feather ni. Sea feather punya organ tengah-tengah dipanggil sebagai calyx. Dekat sinilah terdapat dia punya mulut, dia punya anus dan beberapa organ dalaman dia yang lain. Dan di sekeliling calyx ni, dia akan ada beberapa arm tau. Arm dia ni ataupun kita panggil rays lah kan, dia akan ada satu macam bulu-bulu pelepah kecil-kecil yang korang nampak macam bulu-bulu halus tu, dikenali sebagai pinnules. Pinnules ni, kalaulah dekat sea feather ni banyak pinnules dan banyak arm, dia akan equal to banyak surface area. The more surface area pada sea feather akan membolehkan dia punya effort untuk berenang itu rendah. Jadi kebolehan dia untuk berenang menjadi tinggi. Sebab itulah korang nampak yang dia berenang macam ni ialah sebab dia punya surface area dah besar. Kiranya pinnules dengan arm ni macam parachute lah kepada sea feather supaya dia boleh berenang dan terbang dalam air. Kenapa dia perlu bergerak macam tu kan? Sebab bosan ke saja-saja nak berjalan ke kan? Ada beberapa sebab lah kenapa sea feather bergerak macam tu. Satu, untuk lari daripada predation. Contohnya, kalau dia duduk kat satu tempat tu mengancam dia punya kebolehan kena makan lah kan, semestinya dia nak bergerak ke tempat yang mengelakkan dia kena makan. Jadi dia perlulah bergerak macam tu. Tapi korang kena ingat juga yang kelajuan dia taklah selaju macam burung terbang dekat udara. Faktor lain kenapa dia bergerak macam tu ialah contohnya kat kawasan yang dia duduk tu dah macam tak ada makanan. So bila tak ada makanan, mestilah dia nak bergerak ke tempat makanan yang ada makanan. So bila dia nak bergerak ke tempat yang ada makanan, dia perlu berenang ke tengah-tengah kawasan air tu, dan lama tak lama kalau ada arus, arus tu akan bawa dia pergi. So dia dengan bantuan arus dan keberenangan dia tu boleh menyebabkan dia berada kat tempat baru yang mana kemungkinan ada makanan yang lebih tinggi. Selain daripada dia boleh berenang macam korang nampak dekat video kat YouTube, kadang-kadang numbers of arm tu terlalu banyak tau. So bila numbers of arm terlalu banyak, dia menjadi berat. Bila berat sangat, dia tak boleh nak berenang yang korang nampak dalam video tu. Jadi apa dia buat ialah dia menggunakan arm tu untuk merayap dekat kawasan dasar laut. So tak semestinya lah feather yang ada pada si feather ni kegunaannya untuk berenang. Dia boleh juga untuk berjalan dan merayap dekat dasar laut. Abang, macam best je bela benda ni kan, letak kat akuarium, boleh berenang-berenang dalam akuarium je. Ada beberapa spesies yang saya pernah nampak lah orang bela dekat akuarium. Tapi korang kena ingat, bila bela kat akuarium, kebolehan untuk korang nampak dia berenang tu sangat rendah lah, sebab akuarium tu pendek. So rather than dia guna effort untuk terbang dalam akuarium yang kecil tu, lebih baik dia berjalan je, merayap. Lagi efektif untuk bergerak daripada satu point ke satu point. Soalan terakhir, sea feather ni ada dekat Malaysia ke tak? Mesti korang nak tahu kan? Jawapan dia ialah sea feather ni widely distributed. Maksudnya dekat seluruh dunia, selagi mana ada air laut, sebab dia memang exclusively ada dekat laut, selagi tu korang boleh jumpa sea feather ni. So konklusinya kat sini, sea feather ni bukanlah sesuatu yang rare pun, tapi sebabkan jarang orang buat coverage dan cerita tentang dia, kita pun nampak macam rare. Dan movement dia itulah yang menyebabkan rare dan kenalah dengan namanya, iaitu sea feather, pelepah laut.
So, like the video state that the sea feather sometimes will wrinkle their arms to move or to fly, like it look like they are flying, swimming. But sometimes if the arms are too heavy, too much arms, they are too heavy, they are crawling like the starfishes. Okay, let's go to the next slide. Okay, next we will learn about Hollanthrodia. So Hollanthrodia has a water vascular system. They have a water vascular system for that accommodates the elongate body of the Hollanthrodia. So water vascular system accommodates an elongate body of the Hollanthrodia, but rather than they use the seawater, they use the coulamic fluid through the water vascular system in their body. So for other echinoderms, they use seawater to circulate through their body for the water vascular system, but not for Hollanthurians. The Hollanthurians will use the coulamic fluid to circulate through their body for the water vascular system. The first, a ring canal around the gut has 1 to 50 Polian vesicles, which may function for hydraulic regulation. Each ring canals has a row of ampullae. They have a rows of ampullae. So podia is the external portion of the tube feet, may be suckered, reduced, or lost. These podia are most randomly scattered along the body than in other echinoderms. Okay, so let's move. Okay. The esophagus, gut and radial canal. The esophagus, gut and radial canals of the water vascular system are supported by what we call as calcareous plate. Remember calcareous plate? The mandrillopori is unattached to the column and is internal, lying beneath the pharynx in the CD interambulacral position. So the mandrillopori is in the body of the Hollanthurians. They are not outside. They are not outside. They are not external. They are internal organ. So This mandipora are lying beneath the pharynx, what we call pharynx, in the CD interambulacral position. So a short stone canal follows the mandipora, while support in the most echinoderm is from the skeletal structure. In sea cucumber, thick sheets of the body muscle provide the support. For other echinoderms, they use their skeletal structure, like the plates, the calcareous plates, like the calcium carbonate plates. Okay, so like and the calcite ossicle or calcite plate. So for the sea cucumber, the holothurians, they use a thick sheets of body wall muscle to provide the support, not the plate. Okay, so the microscopic ossicle, also called as sclerates, on the dermal layer are used in taxonomic identification. These sclerates also provide support, and they are used in taxonomic identification to differentiate them with another. So this is the sea. This is a sea cucumber. This is a sea cucumber. Okay, so this is the gonad. This is the stomach. This is column. This is what we call column. This is the mandripore, or the mandripore. This is it at the internal organ. They are here. Okay, sorry, let me use another color though. Okay, let me use another color. The arrow in the picture is already red. Okay, so this is the mandripore or the mandripore. This is the ring canal. This is the pharynx. This is pharynx, and this pollen vesicle. This is what we call pollen vesicle. They have 1 and up to 50 pollen vesicle per holothurians. This is the intestine. This is the anus, and this is the column, stomach, and the gonad. Here is the gonad.